So we're going to dig into variance and the big difference here between population and a sample is what we're going to dig into today. Yesterday we looked at the standard deviation of a population. So let's restate that formula there before we actually start. So the standard deviation of a population was the square root of, and we had here the sum of each data point minus the mean of the data, so mu, and we were squaring that and we were dividing that by the number of data points there are. So it's almost like an average of the data of, and almost like an average of the differences of each data point from the mean of that data point, if that makes sense, right? So we looked at that. We learned how to calculate it. We learned also that this was though we now know the steps of calculation, it's not very useful for us because in general, data sets tend to be very big, and calculating the standard deviation of a data set is, even a small data set, is very time consuming. But it's something we can do, right? Especially with small data sets. What we want to actually look at today is the difference between an entire population and a sample of a population. Well, let's say, for example, let's look at this question here for starters and kind of just start digging in just with a case in point. Here we found the following ages in years of all 4 bears at the local zoo. All 4 bears, right? Well, let's imagine like there's all the bears in the world, right? Okay. So this is not, maybe I should have done a sphere for the world, right? Okay. So all the bears in the world. This here is all the bears in the world. Okay. Well, to find the standard deviation of the ages of all the bears in the world would take us a terribly long time. And indeed, if we even tried to do it, we would be into spreadsheets. And as we were doing our calculations, maybe more bears would die and more bears would be born. And so our data would actually change. But based on a data set, what we can actually do is we can take a sample. And a sample of this, all the bears in the world, might be one zoo. Right? Okay. And so that might be a sample of all the bears in the world. And we could examine this sample and discuss and based on this sample, say things about all the bears in the world because of what we found, right? So what's the difference here? When we're looking at these questions, first of all, we're going to be told all the bears at your local zoo, or we're going to be told something along the lines of, well, a sample of has been taken of all the bears in the local zoo, and here they are. Okay, so we do need to distinguish between the two here, because if we've been given all of the bears in the local zoo, which we have, then we need to go back to our standard deviation formula right here. But if we're looking at a sample, well, things change a little bit. Okay, so the standard deviation of a sample, and we saw this briefly yesterday. The standard deviation of a sample is a similar idea. It is the sum of x minus, and we call this x bar. It's the same thing. It's really the same thing as mu. And we've got n minus 1 down here to compensate for over and under, right? For our sample being potentially over or under the actual amount, right? So it's like the n minus 1 here is a compensation, right? The x bar is a mean of, so the x bar is a mean of the sample. So it's the sample mean is what x bar is, okay? Whereas mu is the mean of all of the data. X bar is the mean of just the sample, so it's not necessarily the whole data, right? And so because we're just taking a sample, we then need to compensate and do this here, right? So our variance then is something different. This is a standard deviation of our sample. Well, our variance is the standard deviation of the sample squared. So that's s squared. We say that s is our S standard deviation of our sample, and our variance is S squared. And so this simplifies things a little bit, takes out the square root, means we just have this, the sum of x minus x bar and square that and take that n minus 1. And there we have it. Okay. And notice that we'll be given a variance is always squared, right? So a variance is S squared, right? Now, here's the thing. Here's the thing here, right? A variance can also be a variance of a population, right? A variance of a population will also square both sides here, right? Okay, so the variance is just S squared. So a variance here is S squared also. So we square both sides. So we're basically just taking away the square root. Okay, so just be aware of that. These are the two different formulas we're going to use, and we're going to use both of them in this problem set, right? So just be aware of that. Okay, it's all based on whether or not we're examining all of the population or a sample of the population, right? So the following ages of all 4 bears in the zoo. Well, what's the average age? That's the mean age, right? The mean age is 5 plus 4 plus 6 plus 39. An old bear, young bears, divided by 4. And so that is, what is this? 54. So 54 divided by 4. I think that's 54. 54 divided by 4, which is, well, we might have to round it to the nearest tenth. Let's pull out the calculator here and make sure we get it right. My mental arithmetic is not necessarily perfect here. 13.5, right? So we've got 13.5 is our average age. So what is the variance of this data? Okay, well, the variance of the data, we're going to use the standard deviation because we've got the entire population, right? And we're going to use the variance of this. So we're going to look at our variance being, so we've got ourselves, we need to find our use a table right here. If we've got x, well, what is x minus mu squared, right? That's what we need to find here. So we've got a 5, a 4, a 6, and a 39. Okay, so this is going to be 5 minus 13.5, right? And that's going to be squared, right? This one here is going to be 4 minus 13.5 squared. This is going to be 6 minus 13.5 squared, and this is going to be 39 minus 13.5 squared. Okay, so let's figure each of these out using a calculator. All right, so the first one here is 5 minus 13.5, and we're going to square that. Is 72.25. And the second one is going to be 4 minus 13.5. And we're going to square that. 90.25. The third one is 6 minus 13.5. And we're going to square that. Oh, careful, we did 66 there by accident. Let me do that again. Clear that. 6 minus 13.5. And we're going to square that. 56.25. And the last one's 39 minus 13.5. And I don't know, has anyone else noticed this strange calculator on Khan Academy, which seems to keep the negative on squares, which is kind of unusual. But just it's doing that because the negative is, it's assuming that the negative is outside the parentheses. So just be aware of that. So this is 25.75 squared, 663.0625. Have I done that right? 39 minus 13. Oh, yeah, no, I did that right. That's 13.5. That 39 minus 13.5. And now we're going to square that. 650.25. Okay, so now we're going to take the average of those, essentially, is what we're going to do. So we've got, so our this whole sum, right, the average of those is, the average of those is 72.25 plus 90.25 plus 56.25 plus 650.25, and that's divided by 4. And that's 217.25. So is 217.25. And so we're looking at 217.25. Right? Notice here that these are squared, so we don't have to worry about the square root anymore. Let's take a look at another question, right? And this is important to take a look at a second question. We notice in this second question that we've got that our tigers here are randomly selected from the 31 tigers. So we have we're using here a sample, right? So a sample, so our s squared is now going to be equal to the sum of x minus x bar squared all over n minus 1. So there's a difference here as well, okay? So similar to the other one, we do everything else the same, except right at the very end, we're going to do it divided by n minus 1. So otherwise, it's all exactly the same, right? A sample, a randomly selected sample, we call it x bar. It's basically the mean of the sample mean. And because it's a sample, we use n minus 1. With a population, we divide by n. So here's what we're going to do. We're going to get our x bar first of all. X bar is 22 plus 13 plus 18 plus 16 divided by 4. And that is, pull out the calculator. This is where everything slows down. 22 plus 13 plus 18 plus 16 equals, gotta do that again, 22 plus 13 plus 18 plus 16 divided by 4, 17.25. So we've got 17.25. Let's do our table right here. We've got our x and our x minus x bar squared. All right, so x is going to be 22, 13, 18, and 16. What's x minus x bar going to be? So we've got 22 minus 17.25 squared. We've got 13 minus 17.25 squared. We've got 18 minus 17.25 squared, and we've got 16 minus 17.25 all squared. All right, so 22 minus 17.25. Again, we're going to need our calculator for this. So we've got 22 minus 17.25, and we're going to square that. That's 22.5625. We've got 13 minus 17.25, and we're going to square that. 18.0625. We've got 18 minus 17.25. That gives us 0.75 squared. $0.5625. And then we got 16 minus 17.25, which is, let me double check that previous one, because I suddenly don't believe myself. 18 minus 17.25 is 0.75. Good. So 16 minus 17.25. And we're going to square it, is 1.5625. So we've got 1.5625. Now we're not just going to find the average of this. Let's be careful with this. We've got an n minus 1 here, so we only divide by 3, right? So what we're going to do here is we're going to add all these together. So we got our 22. We got this sum of all this, right? That's your sum, right? Your sum of, so we're going to sum of that divided by n minus 1, right? So divided by 3. And so we have now, we have our 22.5625 plus 18.0625 plus 0.5625 plus 1.5625. And we're going to divide that by 3 to compensate for it being a sample, and we get a 14.25. And so here's our how we're going to summarize all of this. Our average age is 17.25, and our variance in this case here, because it's a sample, is 14.25. All right, this is quite time consuming. I'm going to leave you to that. Just remember your two formulas that you want to use. You want to start with your standard deviation formula, but what you're looking at is your variance is based on your standard deviation formula, right? Remember, your standard deviation formula is the square root of the sum of x minus mu squared all over the number of data points, right? That's your standard deviation. Remember that the s squared is the standard deviation squared, or s squared is the standard deviation of a sample squared, right? And just remember the sample is slightly different because the standard deviation of a sample is the square root of the sum of x minus x bar squared over n minus 1. And so for variance, if you've got a sample, right? If you've got a sample, you go with this one. If you've got a population, you go with this one. So for sample, right? Random selection, right? So the variance of a sample, random selection, we're looking at the sum of x minus x bar squared over n minus 1. And for a population, we're going with the sum of x minus mu squared over n, right? So those are the two that you got to work with.